Downhole sensors (DHS) are devices installed to monitor, measure and transmit data on fluid flow, fluid properties, and other well performance data. DHS include permanent pressure and temperature gauges, distributed temperature and pressure sensors, sand production sensors, seismic sensors and single, multi-phase flow meters. Although reservoir monitoring via permanent pressure sensors can be traced back to the 1960s, the integrity of the data obtained is questionable due to the potentially imperfect data influenced by wellbore thermal effects. To solve it, we have to address the gauge placement issue by keeping the points below while installing downhole pressure sensor. Pressure gauge is placed as close as possible to perforations. For sensors without sand control, mandrel with pressure gauges near the perforated zone can be placed. For stacked completions without sand control, the gauges can be run in the producing zone. Undesirable leakage of the injected fluids to adjacent layers may affect underground water and hydrocarbon resources. Leaky well and leaky faults can be detected using analytical solution using pressure transient analysis based on two-layer system. Mosaheb-Zaiduni 2012 simplified the dimensionless pressure difference equation as shown. First, the leakage pathway is identified by plotting the dimensionless pressure difference of two observation wells. Second, the characteristics of the leaky well are calculated using the pressure data of the observation well. Lastly, locate the leaky well by assumed as triangle using the trigonometry. Oil and gas industry are now focusing on producing from shale and tight gas reservoir. The development in unconventional reservoir had been enhanced by horizontal multi-stage fracturing technology. Once produced, there are fractures that are not effectively produced but no detection can be made which fractures are ineffective. Graph shows effective fracture interval fractures pressure transient log-log type curve. Comparison 1 ineffective fracture with 3 ineffective fractures. Value of y-axis from first horizontal line to all fractures effective in 3 fractures ineffective increases compared to 1 fracture ineffective. Build-up test usually utilize downhole gauge to estimate bottom hole pressure. Newly developed fluid level measurement system enables Reservoir Engineer to estimate bottom hole pressure during build-up test of a flowing well. The schematic of the system is shown below. It utilizes a complex acoustic signal pattern at specific, varying frequency bands. This signal pattern is generated purely electronically by the acquisition unit and is transformed into an acoustic signal pattern in the transducer sensor device. With this technology there is no need for a gas gun anymore to generate a pressure pulse. The results from this example suggest that the method of determining pressure build-up curves from fluid level measurements provides a reliable means for obtaining bottom hole pressure data. Even if downhole gauges cannot be installed close to perforation depth, well deviation was not found to be a limiting factor. In the numerical procedure, the well path is accounted for when calculating the pressure gradients in the gas and liquid columns. The maximum well deviation in the examples presented here was 45°, well V043.